Today we're going to be looking at the laws of logarithms. The laws of logarithms are very handy because they allow us to unravel a lot of very complicated logarithmic equations and statements, do a lot of simplifying. Let's start off with the first law. The first law looks like this. If you take the log of a product to whatever base you want, okay, so log of x times b, product of two numbers, we can expand that out by adding two separate logs. Okay, so I have log of x times y, base b, can be expanded by log of x plus log of y, base b. Now it's not really surprising to us that this expansion exists because after all logarithms are totally related to powers and exponents. And if you think about it, we have a rule that says if you're multiplying two powers together and they have the same base, and this has the same base business going on, and what do we see when we're multiplying with exponents? We're supposed to add exponents. So not that dissimilar here. We have a product, multiplication, and it's expanded by addition. So not totally surprising. Our second law has to do with if you take the log of something divided by something. We'll say base b as well. How do we expand that? Well, very consistently to our first law, we would have log of the numerator minus log of the denominator. So as you can see, if we're dividing, it's a subtraction or a difference of logarithms. One of the most handy of these laws. What if you're taking the log of something raised to an exponent? Really, really handy. We can bring that exponent out front and multiply it by everything that's left. Very, very handy, as you'll see with my examples coming up. And lastly, what about the log of the nth root of something? Now, I think of this fourth rule as a kind of spin-off of the third rule, as you'll see. And here's my reasoning. If I'm taking the nth root of x, I could write that as x to the 1 over n. And now I'm back to rule number 3. I've got an exponent, so I'm going to bring that exponent out front. Now, there you have it. These are the very important rules of working with logarithms. What I'm now going to do is work through a number of examples and show you how these laws help us to unravel very, well, in some cases, very messy logarithmic stuff. So, let's get a little board space, see what we can get here. All right, let's see what we've got here. My first example, start off gently. What if you have something like this? Log base 7 of 49 to the 5th. Okay. Well, here's that rule number 3. We have an exponent. So I'm going to start by bringing the exponent out front and go 5 times the logarithm, base 7 of 49. And all I've got to do now is say to myself, log 49 base 7. Well, 7 to what exponent equals 49? It won't take you long to figure out 7 to the 2, or 7 squared, equals 49. So what's my answer? 10. Not too bad. second example. I'm going to try and simplify something like this. Log base 3, the fifth root, 27. All right, let's try and make sense of this little mess. I always like to change radicals like this to exponentials, so that's what I'm going to do. Some people wouldn't do it this way. So, instead of the fifth root of 27, I write it as 27 to the 1/5. So I'm going to take that 1/5, the exponent, and bring it out front. So I have 1/5 times the log of 27 base 3. And now I'm going to convert this just by thinking to myself, 3 to what exponent equals 27? Well, that's going to be 3 cubed, 3 to the 3. So my exponent that I want here is 3, and there's my answer, 3/5. So now we're down to a couple examples under our belt. Not too bad, not too bad. Little board space, and we'll get on to some more complicated ones. Okay. All right. Now, let's see here. The next one I'm going to do doesn't involve too many numbers. What I'm going to try and do is combine a bunch of logarithms. So it's a little bit like working backwards with these laws. So I'm going to take log A minus 3 log B plus 5 times log of the fifth root of C. So we got all kinds of messy stuff going on here. What we're going to try and do is combine these 3 logarithms, which are all common logarithms, so all base 10. And if the bases were different, I could not use the laws of logarithms. If you go back and check, maybe if you've taken some notes, these all have to have the same bases in order for these laws to be enacted. So that's just a little observation. They're all base 10, so I can do this. So I'm going to start putting this stuff together. Well, first let's bring this 3 in as an exponent. So I'm going to write that as b cubed. And I'm going to bring in this 5 as an exponent, but that's kind of a funny one because what I have here is the fifth root of C all raised to the 5. Well, if you think about that, if I'm taking the fifth power of a fifth root, these things kind of undo each other. So what I actually just have is log of C. So here's what I have, which I'm going to try and combine. So it's a lot simpler just by bringing in some exponents. Now, if I take these first two, I'm subtracting, which means I could combine them by writing this as division. A over b cubed. Then I still have this, plus log C. Well, these two logarithms are being added, which means multiplication. So here we go. I'm going to combine this times this. So I'm going to keep it in alphabetical order and write A times C all over b cubed. There it is, combined as one logarithm. Now, fairly lengthy, but I think once you get pretty good at this stuff, you probably wouldn't be as careful in writing each and every little step. You might, for example, jump from here right down to this step and maybe even do a lot of these combinations already, fuse these steps together. Why not? Okay, let's do one more example here, show you how the logs can be broken down in, well, I guess what would be maybe our most difficult example for today. Better get lots of the board space for this one. Oh boy, I hope it's not too tough. Alright, let's see what we got here. Alright, now in this one, we're going to give you some information. Okay, so we're going to say x is defined to be log of 5 base 4 And we're going to say y is defined to be log of 3 base 4. That's kind of given information. Okay. Now what we're going to try and do is take this log of 225 base 4, and what we want to do is express this thing here in terms of x and y. Now, what do we mean in terms of x and y? Well, what it means is we want to try and rework this thing and get it just so that it has x's and y's, maybe not both, maybe both, maybe something like 4 times x minus 3y or something like that, who knows. But that's what we want, just in terms of x's and y's and possibly various numbers. So we've got to figure out some way of unraveling this. What we have to start off and do is say, well, maybe we could write the 225 with 5s and 3s or something like that. Now, I can't help when I look at this. I think of 225 and I think, well, I know that 25 is a factor of that number. Maybe that's going to get us somewhere. So I'm going to think of it as 25 times, now how many 25s go into 225? I think 9 do. So I'm going to try this. Now this is just a try. If this didn't pan out, I would go back and try something else. But I think this will work because what I can now do, since I'm multiplying, is I can break these up as follows, using addition. Okay, well that's got us somewhere. Now I look at this 25 and I think, I do have a 5 in the picture. I do have a 3 in the picture with this 9. So I'm going to try rewriting that 25 as 5 squared. And I'm going to try rewriting this 9 as a 3 squared. Why would I do that? Well, I can bring these exponents out front, so I'm going to have 2 times. Now what's left, of course, is log of 5 base 4, which is just x. So I'm going to have 2 times x, plus, I bring my exponent out front with 2, and I've got log of 3 base 4, and that's just y. There's my answer. 2x plus 2y. Not too bad. Now sometimes these can be very, very slippery indeed. But sometimes they're not too bad. Practice makes perfect. Anyway, I think that's all for today. So